Hello everyone, I'm Gülin Yazıcıoğlu and I will present you our research on the assessment of building energy performances by building envelope. This research paper formed a part of an elective course about sustainability and life cycle analysis of civil engineering structures at Middle East Technical University, together with my colleague Damlanur İlipınar and our instructor, Assistant Professor Dr. Güzide Atasoy. First of all, I will start with the introduction and then talk about the methodology, which we have used Tally Revit plugin and Autodesk Insight as our main tools. After that, I will be presenting our results and discussing what we achieved at the end of the research. At last, I would like to mention what kind of challenges we have faced during the process and conclude our research paper. Well, when we reviewed academic literature about beam-integrated LCA studies, it can be seen that they are mostly carried out in the scope of whole building components, and LCA of different materials is evaluated from the perspective of facade design. But the combination of generally common glass types, which are flat, double, and double E-low glass, has not considered for LCA of facade component. When we come to our problem statement, according to Global Studies report in 2017, office buildings are responsible for large amounts of energy consumption. The required heating cooling energy and the used electricity in office buildings constitute 33% of the total energy consumption of Turkey. At this point, facade system of office building is very crucial component to reduce this energy. Therefore, it is necessary to evaluate different configurations for the office building's facade in order to improve overall energy performance. While we are starting to our research, we ask two main questions. First one, what is the environmental impact of two facade opening types with different glazing types throughout their entire life cycle? Second question is, what's the total energy usage of the office building in the view of both facade design options and three different glass types? Our aim was to identify how choosing three different glass types impact the office building's energy consumption and its life cycle assessment. Objectives are analyzing the environmental impact and energy performance of two facade options with three different glass types, and presenting LCA of different facade configurations in the perspective of carbon dioxide emission and energy performance. Well, as it's seen, we have two design options of a newly constructed office building in Ankara. The first one is a fully glazed facade. However, the second one has wall and window. The building has 3 levels and 400 square meters footprint. The structural system is reinforced concrete frame, and we consider the service life as 60 years. According to framework of the methodology, on the top of everything, I would like to highlight that only facade systems are investigated. Other systems like structural and mechanical ones are not included. For life cycle analysis, we use Tally Revit plugin, and energy consumption we use Autodesk Insight. So this screenshot is from Tally's report that explained the calculation methodology. Tally uses ISO 14044 and other American standards. Our functional unit is 1 square meter and the database from Gabi 2018. The system boundary is the cradle to grave life cycle. During the calculation process, we had to exclude construction installation and operational energy due to not being mapped in Tally's database. There were only American cities to include those energy data. These pictures are from our facade design options. Design option 1 has curtain wall system with aluminum mullion and 3 different glass types. Second design option differs from the other one. It has walls and windows. For the openings, they are same as option 1, but walls consist of brick in the core, EPS for insulation, and paintings. About the transportation of materials to construction site is one of our challenges that we had to customize it manually. We paid attention to choose materials from local suppliers, except brick. It was imported from Eskişehir. You can see the table of distances here. Also, we assigned service life for the building products. For maintenance and replacement phase, it includes the replacement of materials according to their service life. The expected service life of used products is identified separately, as is shown in Table 1. Well, when we come to the results, for the flat glass type in the partially glazed facade option, it has 1.3 tons of carbon dioxide emission per square meter by year, whereas the flat glass in fully glazed facades emits 0.35 tons of carbon dioxide emission per square meter by year. For the double glass, the partially glazed facade option causes 1.38 tons of carbon dioxide emission per square meter per year, while the fully glazed facade option causes 0.63 tons of carbon dioxide emission per square meter per year. At last, for the double E-low glass, global warming potential of fully E-low glass facades constitutes 42% of the carbon dioxide emission of wall plus E-low glass window facade. E-low glass in wall and window facade emits 1.5 tons of carbon dioxide per square meter by year, and E-low glass in fully glazed facade emits 0.6 tons of carbon dioxide per square meter per year. So, when the results are compared, a fully glazed facade with a flat glass alternative is more environmental friendly with respect to carbon dioxide emission and global warming potential. The carbon dioxide emission of the wall and window facade is always higher than the curtain wall, which means that brick raises the global warming potential. When we look at global warming potential results divided by life cycle stages, the carbon dioxide emission of production module is significantly higher than the other life cycle stages. For the flat glass alternative, carbon dioxide emission of glazing production in the curtain wall facade is less than carbon dioxide emission of masonry production in partially glazed facade. Okay, this slide is part of Autodesk Insight results. It was thought that glass surfaces cause high thermal loss in buildings. However, line 1 shows almost the same amount of consumed energy in two design options. When we look at line 2, it equals to 86 houses worth of heating energy or 612 houses worth of electricity demand per year in Turkey. When we look at the line 3, it equals the energy needed to heat 264 houses or electricity demand of 1883 houses per year. Before I'm coming to conclusion, I would like to mention what kind of limitations we came across during the research with calculation tools. The tool we used for LCA analysis was Tally, and Tally's database only works with US standards. Therefore, transportation data in Tally is entered manually for Ankara. On the other hand, operational and construction installation energy related to the map could not include it. Moreover, Tally Material Library has limited alternatives for glass types. Therefore, we had to enter each layers of double E-low glass in Tally manually. Well, at the end of this research, we found that global warming potential of two different facade designs differ greatly. The global warming risk of an office building with a wall window facade is at least 2 times higher than a fully glazed facade. According to Autodesk Insight results, the amount of energy consumption of building is considered during its service life, which is defined 60 years. It is observed that the most energy efficient choice is the design option 1, which is fully glazed facade with double low E glass. On the other hand, fully glazed facade with flat glass has the highest energy usage among other glass type alternatives. Consequently, a fully glazed facade with a flat glass alternative is more environmental friendly with respect to carbon dioxide emission and global warming potential. On the other hand, double E-low glass has more potential with regards to reducing energy consumption. There are no definitive or widely accepted judgments about which criteria or impact category should be priority. Therefore, from the sustainability perspective, it depends on the stakeholders' choice. Well, our research presentation ends here. Thank you for kind attention.